Assalamu alaikum warahmatullahi wabarakatuh. Right there, I'm gonna show you how to represent a DC shunt machine using MATLAB. First, let's go to library, Simscape, power system, specialized technology, fundamental blocks, machines. Let's get the DC machine block. Since we got Simscape, it won't compile unless we got the power JUC block. After that, let's go to Camelia's block, bus selector, constant block, and scope block. And there's our remaining thing, that is the DC voltage source. Here's the DC that we want to use. Here are these all blocks that we want. Let's fit them in shape, Ctrl R to maintain the position. After that, let's take this scope. Yeah. Let's delete this and this one. Let's take that continuous power JUC here. We don't want to do anything with it. The constant, we'll put it here for input value, and here for the output scope and bus selector. We can see here clearly for the DC machine some specifications, which F plus and minus represent the field and A plus and minus represent the armature. Here is the input, now it's a torque, and here is the output. Double click on the DC machine. Now here we see a present model. There are some specifications for all DC machines that we are using. We're gonna use this one, which is the 5 horsepower output, 240 volt for armature, 1750 RPM for DC machine, and the field volts 300 volts. We can see here the mechanical input, which is down there. Now it's torque. Also there is a speed, and you have to notice if you use a torque as an input, the output will be speed, and when you use speed as an input, the torque will be the output. And it depends on how, if you doing a motor or a generator, we'll keep it as a torque input. Now let's connect the blocks together. Constant for the torque input, and here the armature. We'll connect it to the volt source, plus with plus and minus with minus. And since we are doing the shunt, so they will be in the same line with the field line. Here we are. The output will connect it to the bus selector. Double click on the bus selector. We see here selected signals, signal 1 and 2. We're gonna remove them, we don't need them. And here we can see that speed, armature currents, field current, electric torque. We're gonna select them all, click them all, click OK. Now we have 4 outputs. Double click on scope to keep it fit to the bus selector. File, number of input ports. We're gonna use 4. 4 and 4 are equal, so let's connect them together. Here we are, speed, which is in radian per second, armature current in ampere, field current in ampere, and electrical torque. Here we're done for the shape. Let's run it, compile. Before we compile it, let's change the value of source and the torque to get what we want exactly from the shape. Let's combine. Okay. Here let's change the voltage. Let's pick 240. And here a constant for the torque. Let's pick 50, for example. 15, sorry. Now run it again. Done. So let's go to the scope. Can see here 4 different lines. Each one means a single output, but we don't know now where is the speed, armature current, and that stuff. If you want to know them, go to the view, configuration properties, display, and show legends. Now all clears. Yellow is the speed, radian per second, armature current is the blue one, red field current, and the green is the electrical torque. To get the precise value or accurate value, we have to use the ruler. Click on the ruler. And we can see, since we move the ruler in any single point, you will see the value here for the ruler 1, and the second for the ruler 2. Here we can see is the speed value is 232.7 radian per second. If we want to change which line the armature current here, we can use it for armature current, and so on and so forth for the field current and electrical torque. In the beginning, I just said a thing about the torque and speed, input and output. And there must be a relation between the input and output. And if we want to know what's the relation between input and output, let's change some inputs to see what will change in the output, which is the speed, since the input is the torque. Let's go with 18, for example, as a torque. Good scope. Run it. Here now the speed is 221.1 radian per second. It decreases a little bit, and if we want change it further as 25, for example, let's see if it increase or decrease. Compile it. It also decreases to 193.8 radian per second. And let's get a small value for the torque to make a conclusion. Let's pick a 10, for example, since we started with 15. Goes here, we run it again and again. You can see the curve is increases further up to 252.2. So now we can conclude that torque and speed are inversely proportional to each other. That means when you increase the torque, the speed will reduce, and when you increase If you want to increase the speed, you have to decrease the torque. Here is the end of the project.